everyone. In this video, we're going to talk about trig word problems involving the angle of elevation and the angle of depression. So we'll start with terminology here before we get into some problems. So angle of elevation and angle of depression. The angle of elevation is the angle your line of sight makes with a horizontal line. And so the best way to visualize this is, let's think about a scenario. I have someone flying in a hot air balloon. So we'll have someone there. And we'll have someone down on the ground here, okay? So for you to understand the angle of elevation here, it says the angle your line of sight makes with a horizontal line. So being on the ground, if you look straight ahead, that essentially creates a horizontal line. Your line of sight is looking up to the object, or in this case, person that is above you. And so this person, when they tilt their head to look up at this person, the degree measurement that their head angled up creates this right here, which is the angle of elevation. On the contrary, we're going to consider that same situation to help us understand the angle of depression. If you look down at an object, it's the angle your line of sight makes with the horizontal line. So going with the same scenario, if we look at someone this time in a hot air balloon looking down at the person on the ground, so we'll start with this picture. The person looking down, that's their line of sight, is the line that I just drew in. Their horizontal line, again, if they look straight out, is going to be that dotted line. And this angle that is formed becomes the angle of depression. Now, there is a distinct relationship between angle of elevation and angle of depression, and I'm going to get to that in a split second. One thing that a lot of students will confuse angle of depression with is a situation like this. The key word in the definition is that when you look down, it's the angle your line of sight makes with the horizontal line. And a lot of students will mistake this sometimes, and when they look at a problem like this, they'll say, okay, this is the angle of depression. And notice that in this scenario, the angle of depression is connected with the line of sight, but notice it's making connection with the vertical line. And so this is not what we want to do. This is not an example of angle of depression, so this is wrong. Last thing before we get into some problems is the connection between angle of elevation and angle of depression. And so with that, I'm going to go back up and do one final drawing of the hot air balloon. So we have this, we have the person on the ground, really quick drawing of a stick figure here. Again, here's your line of sight. So first, I'll take with the blue pen, this right here creates their angle of depression. Down on the bottom, I'll switch to the green pen, horizontal line, dotted line, this becomes their angle of elevation. So you can see that I've connected these two definitions to one another. The relationship between the hot air balloon guy's angle of depression with the person's angle of elevation at the bottom is that these are going to actually be equal to each other. Now, the reason that is that both of these horizontal lines are parallel to each other so that makes these angles alternate interior angles. This is going to help us when we get to some word problems later on in the video. With that being said, let's take a look at a problem. There are two distinct types of word problems. One in which you're going to be finding missing sides of a triangle, and one in which you're going to be finding an angle of elevation or angle of depression. So we'll start with a missing side problem. One asks here, a ladder rests against a building at a point that's 63 feet above the ground. If the ladder makes a 47-degree angle with the ground, what is the length of the ladder? So first thing I always like to do in these problems is draw a sketch to create the triangle that I'm trying to solve for. So this is my building, and we have a ladder that's resting against it. So we have our ladder here. They do tell us the ladder is resting at the top of a building that is 63 feet tall. So there's my 63. And the ladder makes a 47-degree angle, and the key word here is with the ground. And so in this case, the 47 degrees is going to be this bottom angle here. We want to find the length of the ladder. So now is where we're going to use our trigonometry. In this case, 63 is going to be considered the opposite of 47 degrees. X is going to be considered the hypotenuse. Using sine, cosine, and tangent and SOHCAHTOA, we'll see here that opposite over hypotenuse is actually going to be the sine ratio. So we're going to do the sine ratio of 47 degrees equals 63 over x. Now we're going to go over to our calculator, and I want you to be sure, especially if you're using a TI calculator, press the mode button when you turn it on, and make sure that degree up here is highlighted. If that's not highlighted, you need to make sure you hover your mouse over it, press enter, and then press the second mode button to go back to the home screen. At this point now, you can type in sine, type the 47 in, and we're going to get a result here of 0.731. So 3 decimal places is always a safe way to go, although keep the calculator, the value in your calculator, because you can use it later on. Whenever you solve an equation here, you always want to get rid of the fraction. In this case, since the x is in the denominator, I'm going to multiply both sides by x to eliminate that denominator. So now we're going to end up with 0.731x equals 63. And to finish solving this, we're going to divide both sides by that 0.731. I mentioned on the calculator to leave the number there because now you can type in 63 divided by. And since you have that as your previous answer, you can actually press the second, negative key down at the very bottom here, because that is the second answer. It's going to actually reuse the same number up above. So you don't have to type it in again. And so we're going to get our final answer. And I'm going to leave my answer to the nearest tenth here. X is going to be equal to 86.14, so let's call it 86.1. And the units here is going to be in feet. Based on this example on this worksheet, I'd like you to now go down and take a try at, let's go back and actually try number 3. Okay? So take a moment, pause this video, try the problem yourself, and press play when you're ready. Solution for number 3. A couple things I want to note. Angle on incline is going to be how steep the hill is going, hence why I use this down here. And some people may have said 170 yards long and wrote the 170 right here where I box this in. That's actually not going to be the length of the ski slope, the actual slope. I drew the green as like the mountain. So you're actually skiing from the top of the mountain here down. So that's going to be the length of 170. And you can see my work and calculator work over on the side. The last problem we're going to go over together here is number 5. Number 5 asks to illuminate the entrance of an apartment building. A night light is mounted on a 6.6 meter pole. If the base of the pole is 24 meters away from our entrance, we want to find the angle of depression. So this type of problem, we're trying to find a missing angle. And this will be number 5. So let's start with, we have a light post here. We have our light. We also have a building, and we're illuminating the entrance to a door. So the door is here. So the light is going to shine, we'll say at the base of the door here, and that's going to help us create our triangle. Remember angle of depression from the beginning of the video. When you're looking down at an object, it's the angle your line of sight makes with the horizontal line. So the light is at the top. Its horizontal is essentially right here. So this is the angle that we're trying to find. Typically, we use the theta symbol for that. Let's label some of the other things in this drawing. We have a 6.6 meter pole, which is this. And we have the pole is 24 meters away from the entrance. So we have our triangle here, which I'm going to trace out in red. Now notice that the theta that we're trying to find is not part of that red triangle, but as I mentioned earlier in the video, that theta is an alternate interior angle with the building's angle of elevation. So those are essentially the same thing. And so in this case, we're going to be using the tangent ratio for this problem because the tangent of angle theta down here at the bottom is the opposite divided by the hypotenuse, which is going to be 6.6 over 24. Now, when you're trying to find a missing angle, we're actually going to instead use the inverse tangent function. And if you haven't had a chance to look over that, I would take a moment to look at some other previous videos on Canvas here that will help you with that. So I'm going to use the second tangent button to bring up the tangent inverse. I'm going to tell the calculator the ratio that I'm working with, so 6.6 divided by 24. And when I press enter, the calculator is going to give me what the angle has to equal. In this case, we're going to get 15, and again, I'll round it to the nearest tenth, 15.4 degrees. For your final question on this video, I want to have you go ahead and move on to, let's find an angle of elevation, try number 8. Take a moment again to pause this video, try the problem, and can't say that, can I? Press play when you are done. Here's my solution to number 8. As you can see, we have our soccer ball here, terribly drawn by me, going up and hitting the crossbar up top here. So this angle is the angle of elevation as we are trying to find. The opposite side is the height of the goalpost, which is 8, and the adjacent is the length the ball is away from the goal, 10. So I use tangent again. And again, because we're trying to find angle of elevation, we're going to use the inverse tangent on our calculator, and we're going to compute that to get 38.7. That's going to conclude this video. Please take a look at your other assignments and work on some more of these problems. Good luck.